our topic is about inverse trigonometric functions. So we have here properties of inverse trigonometric functions. Now, the goal of this presentation is not to memorize all of these properties, but to familiarize, especially the domain and range of each inverse trigonometric function. So for example, the sine inverse, it has a domain of a closed interval from -1 to 1, and it has a range from -π/2 to π/2. Now we recall that the domain of the sine function is actually the set of R, right? Now, in this case, we only consider the interval from -π/2 to π/2. And the sine function has a range also, which is -1 to 1, which is now the domain of the sine inverse. Okay? Cosine inverse has a domain of this interval, then it has a range from 0 to pi, and tangent inverse has a domain -infinity to +infinity or a set of real numbers, and it has a range of -π/2 to π/2. -π/2 and π/2 are not included in this interval. Okay. Now secant inverse, the domain is a union of the interval -infinity to -1 union +1 to +infinity, and it has a range of a union of two intervals 0 to π/2 and π/2 to pi. Then also the basic relationships of these trigonometric or inverse trigonometric functions. Okay, so we have the graphs of inverse trigonometric functions. Let us examine the graph. So for example, y is equal to sine x. Again, if we consider this graph, then we can say that the domain of the sine function is the set of real numbers. But here we only consider the interval from -π/2 to π/2, which is the specified domain, and has a range from -1 to 1. Okay? So since the inverse, noted by sine inverse, we expect that the domain of this sine function becomes the range. Now, -π/2 to π/2 becomes the range of the sine inverse, -π/2 to π/2, and the range of the sine function becomes the domain of the sine inverse, -1 to 1. The same with the cosine function, from 0 to pi, which is the domain, okay, and the range is -1 to 1. So, here in the inverse of cosine, okay, the range becomes 0 to pi, which is actually the domain of this cosine function. And the domain in this cosine inverse is from -1 to 1, which is actually the range of this cosine function. For the tangent x, okay, from -π/2 to π/2, again, as I've said earlier, it should not be equal to -π/2 and π/2 because of these are the vertical asymptotes. So the graph will never touch this line. Okay, so in this inverse trigonometric function, the domain from -π/2 to π/2 becomes the range, and the range of this tangent function becomes the domain of the tangent inverse. Okay, and also for the secant function. Okay, so for the domain of the secant function, if you are only consider this graph, this part here, so the domain is from 0 to pi, okay, provided that x is not equal to π/2, because at x is equal to π/2, we have a vertical asymptote. Okay, so the range of this secant function is from -infinity to negative 1 union 1 to positive infinity. So here in the secant inverse, we have the domain which is equal to what? Which is equal to, what's the domain? Negative infinity to negative 1 union 1 to positive infinity, and the range is what? The range is 0 to pi divided that y should not be equal to pi over 2. Okay? So we have here evaluating inverse trigonometric functions. So find the exact value. How can we find the exact value, and what does this mean? So when we say sine inverse of square root of 3 over 2, or cosine inverse of negative 1/2, and tangent inverse of 1, what does it mean? So for letter A, what is the sine inverse of square root of 3 over 2? Meaning to say, what is the angle in the interval negative pi over 2 to pi over 2? Okay, whose sine is square root of 3 over 2? So what is the angle in the interval? What is negative pi over 2 to pi over 2? If we go back to the graph or the table, okay, sine inverse negative pi over 2 to pi over 2, it's the range of the sine inverse, okay, but it is the domain of the sine function. So what we are going to find here is the angle that is in this interval whose sine is square root of 3 over 2. What's the angle? The angle is pi over 3. Okay? Pi over 3. For example, from the interval, this side, this one is negative pi over 2 to pi over 2. Okay, so we consider this interval from negative pi over 2 to pi over 2. Now, what is the angle that is in between this interval, negative pi over 2 to pi over 2, whose sine is square root of 3 over 2? Okay, whose sine? What is the angle? Whose sine is positive square root of 3 over 2? To find an angle whose sine is square root of 3 over 2. This one is not the one because it should be positive. This is not the correct one. Then the answer is this one. Okay? It has a sine which is equal to square root of 3 over 2. Then find the corresponding angle. The corresponding angle is pi over 3. Thus, the sine inverse of square root of 3 over 2 is equal to pi over 3. Okay? So when we are talking about inverse trigonometric functions, that means the angle that is in between the domain of the given function. For example, now letter B, cosine inverse of negative 1/2. What does this mean? This means that what is the angle that is in between 0 to pi? Okay, take note, 0 to pi is the domain of the cosine function. Okay, on a smaller interval. The angle in the interval 0 to pi, whose cosine is negative 1/2. So what should be the angle? So from the interval 0 to pi, so we have 0 angle to pi. So we only select, okay, select the angle whose cosine is negative 1/2. So where is cosine negative 1/2? This one is not correct. This is not correct. Okay, how about this? Yes, this its cosine or x value in this terminal point is negative 1/2, right? And what is the corresponding angle? The corresponding angle is 2 pi over 3. Thus, the cosine inverse of negative 1/2 is equal to 2 pi over 3. Okay? For letter C, what is the tangent inverse of 1? This means that the angle in the interval negative pi over 2 to pi over 2, whose tangent is 1. Okay, what is the angle? So, locate the interval negative pi over 2 to pi over 2. Then, you look for an angle, okay, that is in between negative pi over 2 to pi over 2, whose tangent is 1. Meaning, if you have the y-coordinate, because by definition, tangent is y over x, you have the y-coordinate divided by x, it should be equal to 1. Okay? How about this one? If you divide this one by square root of 2 over 2, the answer is negative 1. So this is not the answer. Or 7 pi over 4 is not the correct corresponding angle. How about this? Yes, this is the correct answer. Because if you divide y over x over x, so we have what? Square root of 2 over 2 divided by square root of 2 over 2 is equal to 1. Okay? So what is the corresponding angle? Corresponding angle is pi over 4. Okay? So another example, last example, solve for x if sine x is equal to 1/2. So what does this mean? Actually, this is just the same as the one that we did earlier. So solve for x if sine x is equal to 1/2. This means we are going to solve for the angle whose sine is 1/2. So x is defined as the sine inverse of 1/2. Now, what is the angle whose sine is 1/2? Okay, if the range is negative pi over 2 to pi over 2, it should be the angle. It should be pi over 6. Okay, so here, looking at this graph, this is the graph of sine. Okay, 1/2, the y value, which is 0.5. And what is the x value, the corresponding x value or the angle? It is pi over 6. So therefore, it is pi over 6. Okay? Then you can still use this unit circle in order to solve for the problem or in trigonometric or inverse trigonometric problems. Okay, so hope you like this video and hope you learn something from this video. Do not forget to share the learning that you've got from this video. Thank you so much and God bless.